For centuries, we have been told the pyramids were built by pharaohs. But the layers of rock tell a different story. Water erosion that happened before Egypt. Star alignments that hide a date from 12,500 years ago. Stone monuments that survived the disaster that ended the Ice Age. The evidence suggests something unsettling. The builders of Giza may not have been the first Egyptians, but the last survivors of a lost world. The Sphinx faces east toward the rising sun, its lion-like body carved from one piece of limestone, its features worn down by forces that should not exist in this desert. Geologists who studied the walls around it have recorded vertical erosion channels, grooves carved by water, not wind. Egypt's climate has been extremely dry for over 7,000 years. Rain strong enough to cause this kind of erosion would require centuries of steady rainfall, a climate that ended long before the first pharaoh ruled. The Great Pyramid, 2.5 million blocks, fitted with measurements so exact they can be checked in millimeters, lined up with true north with an error of only 3 arc minutes. Its inside chambers vibrate at frequencies that make the human voice sound louder. Its base covers 13 acres and is so level that it changes by less than an inch across the whole foundation. And above it all, the stars. The 3 pyramids of Giza line up exactly with the 3 stars of Orion's belt, not as they looked in 2500 BC when Egypt's old kingdom was strong, but as they rose on the horizon around 10,500 BC, a date that matches not dynasty records, but the end of the Younger Dryas, the moment Earth came out of a disaster that almost erased humanity. So we must ask, were these monuments built by the civilization we give credit to, or were they inherited? Were the pyramids built to all the dead or to survive disaster? And if the builders understood something we have forgotten, what were they trying to save? Tonight we decode the evidence written in stone, erosion, and star alignment. Evidence that suggests Giza is not the beginning of giant architecture, but its last surviving memory. A record left by those they saw the world fall apart and carved their knowledge into the only thing that could survive extinction. Geometry, proportion, and stars. If this story challenges what you thought you knew, share it. Subscribe for the mysteries archaeology still cannot explain. And leave a comment. Which ancient site do you believe still holds secrets waiting to be uncovered? Beneath the sand that covers the Giza Plateau today lies a geological record of change. Core samples taken by drilling beneath the limestone bedrock show alternating layers of sediment, river deposits, packed clay, and silt carried by water that no longer flows. Inside these layers, scientists have found freshwater diatoms, tiny algae that grow only in still water. They confirm what satellite images suggest. This land, now one of the driest on Earth, once had ponds, streams, and seasonal floods. NASA's Shuttle Radar Topography mission mapped the Sahara from orbit using ground-penetrating radar to see below the surface. The data revealed a hidden network of ancient river systems, huge ancient channels winding under today's dunes, dry for thousands of years, but still visible too. Technology that can see through sand and stone. One of these systems, the Khufu branch of the Nile, flowed right past the Giza Plateau. Sediment analysis dates its activity to a period between 12,000 and 8,000 years ago, when rainfall patterns across North Africa had not yet collapsed. The river would have reached the base of the limestone ridge where the pyramids now stand, providing both transport for huge stone blocks and a reason for people to live in an otherwise unlivable place. But the rivers are only part of the story. Pollen samples taken from lake sediments in the western desert keep a record of plants that disappeared long ago: acacia, tamarisk, and wild grass species that need steady moisture. Fossil remains of hippos, crocodiles, and freshwater fish have been found hundreds of miles from any water source today. Their bones turned to mineral in ancient mud, now uncovered by wind erosion. Rock art across the Sahara shows this lost world in vivid detail. At the Sili Najar in southern Algeria, paintings show giraffes, elephants, and cattle grazing beside rivers that stopped flowing long ago. At Gulf Kebir in Egypt's southwestern corner, hunters track antelope under trees that no longer grow anywhere in the region. Reed boats glide across waters painted on stone walls where today there is only sand and silence. Geologists call this time the African humid period, an age when the monsoon belt shifted northward and rain turned the Sahara from a desert into a mix of grasslands, wetlands, and seasonal lakes. It lasted for thousands of years, long enough for complex human cultures to grow, succeed, and build the knowledge systems that would later shape civilization as we know it. Then came catastrophe. Around 12,900 years ago, Earth went through a sudden and dramatic climate reversal. Temperatures that had been warming dropped back toward ice age conditions. Ice cores from Greenland show the shift happened within just 1 decade, a speed never seen before in geological records. Scientists studying sediment layers from this time have found higher levels of platinum, nanodiamonds, and carbon spherules, signs that match an impact from space or an airburst. The Younger Dryas event, named for a cold living flower that suddenly reappeared in Poland, is recorded across Europe as the boundary between two worlds. Megafauna woolly mammoths. Giant sloths, saber-toothed cats vanished from the fossil record. Human populations crashed. Settlements were abandoned. Entire cultures disappeared from archaeological timelines, leaving only scattered remains in oral stories of flood, fire, and darkness. For North Africa, the effects were huge. The monsoon system that had kept the Sahara green weakened and eventually collapsed. Lakes dried into salt pans. Rivers slowed, narrowed, and finally stopped flowing. Grasslands shrank into scrubland, then dust. Within generations, the Sahara changed from a livable landscape into the extremely dry desert that exists today. The people there had only a few choices: move or die. Most went east, following the one water source that still flowed, the Nile, fed by rain in the Ethiopian highlands and equatorial lakes far to the south. The Nile stayed stable even as the surrounding climate fell apart. It became a safe place that drew survivors from across a dying continent, concentrating people along a thin green corridor with lifeless desert on both sides. If giant structures existed before this collapse in areas now buried under moving dunes, most would have disappeared, worn down by wind, covered by sand, ground down by thousands of years of dryness. Only monuments carved into bedrock, built on high plateaus, or fused to geological foundations could survive the change. The Sphinx and the Great Pyramid, rooted in limestone and granite, may be survivors of that earlier age. Monuments carried through the catastrophe by the same climate shift that erased everything around them. Core drilling reveals the truth in layers. Beneath Giza's surface, sediment stratigraphy tells a story of alternating wet and dry times, each recorded in the kind of soil left behind, the mineral content, and the presence or absence of organic material, with the oldest layers dating to the early Holocene. Researchers found proof of standing water, freshwater mollusks, remains of water plants, and clay left by slow-moving streams. Even the limestone walls around the Sphinx show the wetter past. Deep vertical erosion channels run down the walls, grooves carved not by wind, which erodes sideways, but by water flowing from above during long periods of rain. Some geologists argue this pattern could only have formed during a climate that ended before 7000 BC, pushing the Sphinx's origin far beyond the dates used by traditional Egyptology. If this idea is right, then the monument is older not just than the pharaohs, but older than the idea of Egypt itself. A short recovery happened after the worst of the Younger Dryas was over. Between 10,000 and 8,000 BC, the ice sheets pulled back for the last time. Sea levels stabilized, and rainfall briefly returned to North Africa. The Sahara became green again, though not as much as before. Rivers flowed again, but more carefully. Life returned, but thinner and broken into pieces. This recovery time may have been the real time when Giza was built. The horizon would have been clear then. The Nile, overflowing with seasonal floods, would have provided both water and transportation. The stars, bright in a clean sky, would have been visible with the clarity modern life cannot match. Conditions existed not just to survive, but for giant engineering, star observation, and the exact alignment of buildings to cosmic patterns. Ancient carvings scattered across Egypt's deserts echo this forgotten climate. Carvings at Wadi Hammamat, a dry riverbed in the eastern desert, speak of flowing streams where today there is only rock and heat. Texts near cargo oases describe gazelles and wild cattle grazing beside water that no longer exists. And far to the southwest, at Naphtali, a stone circle older than Stonehenge tracks the summer solstice sunrise with mathematical precision. Its builders were cattle herders living beside seasonal lakes, mapping the sky long before Egypt's dynasties began. When their land became desert, they moved toward the Nile, carrying their star knowledge with them, knowledge that would later appear in the exact alignments at Giza, the calendar systems of the temples, and the star myths woven through Egyptian religion. Maybe they were the ancestors of those who carved the stars into stone. Imagine that moment of change. Rivers fading, forests shrinking into scrubland. The people watching their world die not in one sudden disaster, but in the slow choking of drought that lasted generations. They may have built, not from pride or power, but from memory, monuments meant to outlast collapse, to prove they had existed, that they understood geometry and astronomy, and that they refused to be erased by climate or time. The first stones may have been raised as acts of protection, records carved when the builders realized their world was ending and only stone could survive what was coming. Strangely, it was the desert arriving that preserved what was left. The same dryness that killed life also stopped decay. Papyrus, paint, limestone, granite all survived thousands of years in the open because the rains never returned. Archaeologists call this the preservation paradox. Desolation protects. Egypt's past did not disappear. It was preserved in sand. When you stand at Giza today, under the morning light, you are seeing not civilizations Victory over nature, but the leftovers of nature pulling back. The pyramids are geological fossils of human will, carved monuments to a world that existed when the climate still breathed and the stars rose differently above the horizon. Science now supports what oral stories have long hinted. Egypt's beginnings reached beyond written history into ages when the Sahara was green, the monsoons were strong, and humanity lived near extinction. Its roots are not in isolation, but in cycles of creation, destruction, and renewal rhythms driven by the planet itself. The desert is not empty. It is an archive. Every dune holds data isotopes, pollen grains, fossil dust, whispers of worlds that came before. And under it all, carved into bedrock and coded in star patterns, is a message left by people who survived disaster and tried to pass knowledge forward through the only thing that does not decay. So the question is not just who built the pyramids. The question is, what did they know that we have forgotten? And what were they trying to tell us? The sun climbs higher now, casting shadows that sharpen the geometry of the Great Pyramid's faces. The Sphinx remains silent, its lion-like body facing east, waiting for answers we are only beginning to form. But before we can understand who raised these monuments, we must first rebuild in our minds the world that gave birth to them, a world of green valleys and flowing rivers, of knowledge systems and star precision, of survivors who watched the climate collapse and chose to carve their memory into stone, so it would not be forgotten when the sands returned. Cattle bones were found in the Tenere Desert in 1973, scattered across sand where no cow could live today. Not just a few bones. Thousands. Entire herds preserved in fossil mud. Their skeletons lined up, as if they had fallen together, all facing the same direction, toward the water that no longer existed. The dates came back impossible. 6,000 years old, some older, raising a question no one was asking. If the Sahara has been a desert for 7,000 years, what were cattle doing there? 1,000 years after it should have already died. The answer is not a strange accident, but a misunderstanding. The Sahara did not become a desert overnight. It died slowly, retreating in pulses, green corridors collapsing one by one over centuries. And before that collapse, it was not just livable. It was rich. Between 12,000 and 8,000 BC, the African humid period changed North Africa into a place we would not recognize today. Where today there are only dunes and gravel plains, there once was a network of connected lake systems larger than any on the continent today. Lake Megachad, fed by rivers draining the Tibesti and the Neti, was the size of the Caspian Sea. Sediment pores taken from its dry basin contain layers of freshwater algae, mollusk shells, and fish bones stacked in sequences showing thousands of years of continuous life there. The lake did not just exist. It teemed with life. To the west, Paleo Lake Erewhon stretched across what is now Mali's central desert, fed by rivers whose paths are still visible from orbit as faint straight dips under the sand. Ground-penetrating radar shows their channels reaching hundreds of miles, connecting basin to basin in a hydrological web that supported ecosystems we can now only rebuild from fossils. But the lakes did not stay the same. They rose and fell with monsoon cycles, growing during wet phases and shrinking during dry times, creating a rhythm that shaped both land and culture. Shoreline deposits show repeated rising and falling sequences, beaches buried under beaches, harbors lost and regained by water over generations. People adapted to this rhythm. Archaeologists surveying the Sahara have found over 10,000 sites from the humid period, ranging from short hunting camps to permanent towns with stone buildings, storage areas, and signs of social ranking. These were not small wandering groups barely surviving. They were complex societies with specialized work, trade routes, and cultural continuity, lasting thousands of years. At Gabbero in Niger, archaeologists dug up a cemetery with nearly 200 burials layered across 3,000 years. The dead were buried with grave goods, polished stone axes, ostrich shell beads, bone harpoons with barbed tips made for catching big fish. Some graves held multiple people buried together, their arms arranged in embraces that lasted 6,000 years. The harpoon points are especially revealing. Their design is advanced, streamlined, and almost the same as those used by fishing cultures along the Nile, suggesting knowledge moved across huge distances. Either ideas traveled, or people did, or both. Pottery from this time shows regional differences, but also shared styles. Wavy-line designs made by dragging fish bones or comb-like tools through wet clay before firing appear from Mauritania to Sudan. A style signature stretching 3,000 miles. The method required careful temperature control and understanding of clay minerals. These were not rough pots. They were engineered ceramics. And then there are the towns. At Dakhla Oasis, in Egypt's western desert, digs revealed stone foundations, post holes, and grinding stones laid out in patterns showing permanent homes, work areas, and shared spaces. Charcoal dates place people there around 9,000 BC, putting these communities 2,000 years before the first mud brick buildings appear in the Nile Valley. They were already here, already building, already organizing into societies complex enough to leave building traces. Rock shelters across the Sahara preserve detailed records of what they saw. But these are not simple stick figures. They are full scenes drawn with body detail and perspective that suggest real artistic training. At Jabron in the Tassili Plateau, one panel shows cattle being milked, with the udders clearly drawn. The herders' postures look real enough to suggest they were copied from real life. Nearby, hunters track a giraffe across a painted land of acacia trees and flowing water, branches drawn, dogs running ahead. The detail each spot on the giraffe's hide, the dog's muscles shows the culture that cared about accuracy. These are not myths or symbols. They are records. And woven through the art is evidence of something even more unsettling: awareness of the sky. At several sites, rock panels show circles with lines spreading outward, often placed to line up with solstice sunrises or equinox directions. Whether these are calendars, sky maps, or just designs is debated, but their star alignment is not an accident. It looks planned, repeated across sites too far apart to be chance. The same cultures that painted giraffes were tracking sky cycles, meaning they were not only surviving, they were watching, recording, and passing on knowledge across generations. They had systems abstract enough to encode time itself into stone and paint. But under all the richness, geology tells a quieter story. Holland's studies from sediment cores show a shift starting around 9000 BC. Percentages of Mr. species, grasses, acacias, tamarisks begin to drop. Desert plants increase. The change is small at first, easy to mistake for normal climate change, but the pattern stays the same across many sites, and it moves in only one direction. The monsoon belt was slowly moving south, almost too slowly to notice. But moving. Lake levels started to fall. Rivers that had flowed all year became seasonal. Grasslands that supported big herds thinned into scrubland. The change took centuries. Long enough that no one generation would have called it a disaster. Each community adapted, moved, and adjusted to slightly drier conditions than their parents had known. But adaptation has limits. And what the geological record shows is not a slow fade. It shows a collapse around 6000 BC. The monsoon system failed, not weakened, failed. Rain patterns that had supported the Sahara for 6,000 years simply stopped. In maybe 300 years, barely 10 human generations, Lake Megachat shrank to a small part of its old size. Rivers stopped flowing. Plants withered. The people who had lived there for thousands of years faced a choice that was hardly a choice at all. They moved eastward. The one river that still flowed, carrying their star knowledge, their potter's skills, their understanding of stone, geometry, and time. And when they arrived at the Nile, they did not arrive as helpless refugees. They arrived as the holders of 6,000 years of cultural skill, star watching, and monumental ambition. The question is not whether they built Giza. The question is, what did they build first? There is a layer in soil across North America called the black mat. It appears suddenly in the geological record, a dark band rich in carbon and magnetic spherules, sometimes only centimeters thick. Beneath it, fossils of Pleistocene megafauna, mammoths, mastodons, horses, camels appear. And above it they vanish. The layer dates to 12,900 years ago, and it is not alone. Similar carbon-rich boundaries appear in sediment cores from Europe, the Middle East, and North Africa, each dated to the same narrow window, each marking the same sudden shift. Something happened worldwide at the same time. And when it ended, the world was different. Ice cores taken from Greenland preserved the air. In yearly layers, each layer 1 year of snowfall pressed into ice. Over thousands of years. They give a timeline exact enough to show single decades, sometimes single years. At a depth matching 12,900 years ago, the ice at a shows change sharply. OXYGEN 18. Levels drop. Deuterium levels fall. Temperature evidence shows cooling of 10 to 15 degrees centigrade in a single decade. Not a slow change, a collapse. The climate shock so huge it breaks normal expectations. Earth had been warming steadily for 3,000 years, ice sheets shrinking, sea levels rising, ecosystems settling. Then without warning, the warming reverse. Glaciers that had been melting pushed south again. Temperatures crashed, and the cold lasted more than 1,000 years. Geologists call this the Younger Dryas, named for a tundra flower that suddenly came back in European pollen records after disappearing during the warming. Its return marked a climate that should not have happened to relapse into conditions the planet had already left behind. The speed is what breaks expectations. Climate shifts normally happen over centuries or thousands of years, driven by orbit changes, ocean flow, and solar variation. They do not flip in 10 years. The systems that control Earth's climate, air chemistry, ocean currents, albedo feedback need time to change, decades at least, more often thousands of years. Yet the ice core data is clear. The change happened faster than A human lifetime, faster than communities could adapt. People who knew warming saw deadly cold their children could not explain. The question is not whether it happened. The question is what could cause change that fast. Sediment from the black mat layer contains strange things that do not match normal Earth geology. High levels of platinum group elements, iridium, osmium, ruthenium hundreds of times above normal. Nanodiamonds formed only under extreme heat and pressure. Magnetic microspherules, glass-like pieces made when rock vaporizes and reforms in the air. These are impact signs, but not of one asteroid, which would leave a crater and regional destruction. These signs appear across continents, suggesting breakup, many airbursts, a swarm of objects entering the atmosphere together, lasting above ground in fireballs hot enough to melt sand into glass and throw enough dust into the sky to block sunlight for years. The torrid meteor stream, which Earth crosses twice a year, contains fragments big enough to cause exactly this. And 12,900 years ago, Earth may have hit not the stream's edge, but its densest core. Computer models show what happens when a comet breaks apart near Earth. Debris spreads along the orbit, creating a hallway of impacts over weeks or months. As Earth moves through the swarm, some fragments burn up harmlessly. Others, big enough and fast enough, explode with power measured in megatons. Forests burn, ice sheets crack, ocean surfaces boil, and the ash cloud blocks sunlight long enough to trigger runaway cooling. But the physical damage was only the start. Across North America, 35 groups of large mammals went extinct almost instantly in geological time. Columbian mammoths, giant ground sloths, American lions, dire wolves, short-faced bears all disappear from the fossil record at the Younger Dryas boundary. Not slowly, as climate stress might cause. And at the same time, in Eurasia, woolly mammoths that had survived hundreds of thousands of years through many ice ages vanish. Some remains, frozen in permafrost with flesh and fur, show no disease or starvation. They simply stop appearing in the record. Australia's megafauna giant kangaroos, marsupial lions, threatened wombats had already collapsed before the Younger Dryas. But the pattern is similar: fast extinctions of large animals across continents, packed into narrow time windows that match environmental disruption. Extinctions this big barely happen in Earth's history. The last similar die-off was 66 million years ago, when an asteroid ended the age of dinosaurs. Before that, 252 million years ago, when volcanoes nearly sterilized the planet. The Younger Dryas extinction was smaller, but for the creatures living through it, that difference did not matter. Human populations did not die out, but they broke apart. Settlement patterns across continents show a break at the Younger Dryas boundary. Sites lived in for centuries are suddenly abandoned. Special tool technologies, Clovis points in North America, certain microblade traditions in Siberia vanish from the record. When people return, they often show different tools, different survival methods, different social organization. At Abu Hurair, in Syria, a community that had thrived for 1,000 years as hunters and gatherers suddenly became a farming village. The change happened right as the Younger Dryas began. The meaning is blunt. When wild animals vanished and climate failed, survival demanded a completely different plan. Farming may not have started from clever invention. It may have started from desperation. In North America, the Clovis culture disappeared so completely that for years, archaeologists argued about whether any humans survived at all. They did. The cultural continuity snapped. The knowledge systems, trade routes, and social structures that existed before did not carry into the New World. This is what catastrophe, as it erases not only people, but memory. Oral stories from indigenous cultures around the world keep memories of a great flood, a time of darkness, a world burned by fire and ice. The Hopi speak of the end of the Third World. The Ojibwe tell of a star that fell and burned the earth. Australian Aboriginal stories describe seas rising and swallowing land. Hindu texts describe a cosmic flood that destroyed earlier ages of humanity. These are not myths, as in Madhup's stories. They are memories passed down through 300 generations, changed by time, but rooted in real events. And the events they describe match the physical evidence. The black mat layer, the megafauna extinctions, the ice core temperature crash, the impact clues, everything points to the same conclusion. 12,900 years ago, Earth crossed a line. The world before that boundary was not the same as the world after. And the people who survived carried forward only pieces of what had once been known. So when we ask who built the pyramids, we are asking the wrong thing. We should ask what the builders remembered and how much was already forgotten when they started carving knowledge into stone. The oldest surviving Egyptian text dates to about 3,200 BC. The oldest surviving stone monument may be 7,000 years older, meaning there is a huge gap between what could be remembered and what could be written. The gap not of centuries, but of an entire age of human development. And inside that gap, something had to carry knowledge forward. It was not papyrus. Organic material rots, burns, dissolves in water, and breaks down in sun and moisture. It survives only under perfect conditions: mummification, dryness, burial in sealed rooms, and even then it is fragile. It was not oral tradition alone. Human memory changes, is reinterpreted, warped, and lost over time. Stories shift. Details wear away. After 10 generations, events become legend. After 50, legend becomes symbol. After 200, symbols become rituals no one understands. So the question becomes, how does a culture that has seen collapse preserve what it knows when writing does not exist yet and language cannot be trusted to last? The answer shows up in archaeology, not as words, but as buildings. Göbekli Tepe in southeastern Turkey, dated to 9600 BC, has huge shaped limestone pillars arranged in circles, some weighing over 10 tons. The pillars are carved with detailed images of animals: scorpions, foxes, lions, vultures, drawn with body accuracy. There is no evidence people lived there, no household trash, no fires, no homes. It was not a town. It was a monument built by people who had not yet developed farming, pottery, or metalworking. Yet they had the organization needed to cut, move, and raise giant stone in geometric patterns aligned to the sky. They built not for shelter. They built for memory. The same pattern appears worldwide. At Nabta Playa in Egypt, stone circles are older than Stonehenge by 1,000 years. At Karnak in Brittany, 3,000 standing stones stretch for miles, raised between 5,000 and 3,000 BC by cultures with no writing. At Poverty Point in Louisiana, earth mounds form precise concentric rings aligned to solstice angles, built by societies archaeology calls preliterate. These are not primitive experiments. They are deliberate acts of encoding. Stone, unlike wood, clay, or fiber, resists decay. It cannot burn. It does not rot. It survives floods, droughts, and the shifting of climate systems. And most importantly, it communicates through proportion, alignment, and geometry, things that do not depend on language. A circle stays a circle no matter who sees it. A right angle needs no translation. The ratio between a building's height and base can carry meaning without any alphabet. Math encoded in shape becomes a universal language that survives the death of spoken tongues. But math alone does not keep a story. It keeps a rule. After disaster, when people split up and scatter, when trade networks break and cultures dissolve into isolated survivor groups, rules are what last. The knowledge that stars move in predictable ways, that's certain. Angles make buildings stable, that sky cycles match seasonal floods and planting time. The specific names, dates, family lines, and treaties are lost, but the deeper system survives, carried by those who understood it well enough to rebuild. And across North Africa, survivors moved toward the Nile not because it was familiar, but because it was reliable. Fed by equatorial rains 2,000 miles south, the Nile's yearly flood stayed steady even as the land around it dried into emptiness. It became a refuge not by conquest or religion, but by hydrological certainty. Population along the Nile rose sharply between 10,000 and 6,000 BC. Sites appear closer together. Artifacts show sudden variety: pottery styles, tool types, building methods, suggesting not one simple local development, but many traditions meeting in one place. These were not local inventions. They were inherited grain-growing methods from the Levant, cattle domestication knowledge from Saharan herders, star-watching systems from cultures that track sky cycles for thousands of years, all came together along one river corridor, preserved by the people who carried them and encoded into the monuments they would later raise. But here is a detail that changes everything: the earliest stone structures in Egypt are not in the Nile Delta where the most people lived. They are not in the fertile floodplains where farming was easiest. They are at Nabta Playa in the desert, built by people who lived beside a lake that would disappear within 3,000 years. They built monuments while the lake still existed. That means they knew that lasting things required stone, not towns. That what would outlast them was not the community, but the geometry carved into bedrock. They were already thinking in earth time. By the time people gathered along the Nile after 6,000 BC, this idea was already there. The river gave food, but stone gave continuity. And the knowledge systems that arrived with migrants, astronomical calendars, building proportions, cosmic frameworks, were encoded not in fragile records, but in structures built to outlive the languages that named them. The Nile Valley became more than a refuge. It became a storehouse of techniques and observations built up over thousands of years by cultures that no longer existed as separate peoples. The river did not create Egyptian civilization. It concentrated the inheritance of a much larger world. That means when giant architecture appeared at Giza, it was not invention, it was the final result. The question then is not why the pyramids were built. The question is, what knowledge, already ancient when they were built, was being stored inside them, and why the builders felt such urgency to encode It in a form that could survive not just dynasties, not just kingdoms, but the collapse of climate, culture, and memory itself. Stone does not forget, but it does not explain. It simply lasts, waiting for later people to decode the proportions, alignments, and vibrations carved into its surface. Waiting for us to understand that what we call the start of history may be only the moment when survivors finally had the stability to rebuild what had already been lost. The Sphinx enclosure has walls that do not match the floor. Geologists studying the vertical surfaces around the monument have recorded erosion patterns that are fundamentally different from those found elsewhere on the plateau, not in how much, but in what kind. The walls show deep wave-like grooves running straight down the limestone faces. Some channels go 6 feet into the rock. They are rounded, smooth, and follow the natural layers of the stone in patterns that match long exposure to flowing water. But the Sphinx sits in the Egyptian desert, where it has not rained steadily for 7,000 years. Wind erosion, which dominates the Giza plateau, works sideways. It scrapes exposed surfaces with sand, making shallow, even weathering with sharp edges. The effect is slow, predictable, and easy to spot in geology. Water erosion is different. Rain seeps into cracks, follows stone layers, and cuts channels as runoff gathers and speeds up. Downward, the marks are vertical, strong, and deepest where water flows the longest. They require not rare storms, but steady rain over centuries. The Sphinx enclosure shows that kind of erosion. Comparing nearby structures shows the contrast clearly. The pyramids, mastaba tombs, and nearby temples show erosion patterns matching. Wind and sand scraping horizontal lines, even damage, surface pitting from heating and cooling over thousands of years of desert climate. The Sphinx enclosure does not, creating a dating problem that normal dating methods cannot solve. Egyptologists say the Sphinx was built during the rule of Khafre around 2500 BC, based on style comparisons of the head to other 4th dynasty statues and the monument's closeness to Khafre's pyramid. The timeline is clean and fits the broader Old Kingdom story. But geology does not follow art history. Robert Schoch, a geologist from Boston University, studied the Sphinx enclosure in the early 1990s. His method was simple. Study the erosion, compare it to known weathering in similar limestone, and decide what climate would be needed to make those marks. His conclusion dated the Sphinx's first carving to between 7000 and 5000 BC, during or right after the African humid period, when rain was strong enough to create the erosion seen today. Mainstream Egyptology rejected this not because the erosion was not real, but because there was no supporting archaeology. No tools, towns, or cultural objects from that time pointed to a civilization able to carve giant monuments in Egypt before the 4th dynasty. The reply was simple. Geology and archaeology must match. If they do not, one must be wrong. But the erosion remains. Other researchers suggested other causes. Groundwater rising through porous limestone and evaporating could cause similar damage. Or Nile flooding during high water could have filled the enclosure and slowly carved channels over time. These ideas assume the enclosure existed as it is now during times of more water. But neither cause makes the depth, evenness, or vertical direction of the grooves. Groundwater wicking makes salt crust and surface flaking, not deep channels. Standing water, even over thousands of years, does not have the force to cut 6-foot grooves into solid rock. Rain runoff over centuries does. So the evidence points to a time when the climate was truly different. Not a dry place with occasional floods, but a wetter place with steady rainfall that could erode limestone through repeated rain cycles. Those conditions have not existed in Egypt since the end of the Neolithic subpluvial about 7,000 years ago, placing the Sphinx's digging and first carving before the 1st dynasty, before hieroglyphs, before the pharaohs who later claimed it. But here is the detail that breaks the timeline. The Sphinx's head is too small for its body. Normal Egyptian art keeps steady proportions. The toe-body ratio is around 16 or 17. The Sphinx is closer to 110. And the head, unlike the body, shows weathering that fits later dynasties. Sharper details, less erosion, tool marks like those of 4th dynasty sculptors. The meaning is unsettling. The body may be original, carved from bedrock in a wetter age by cultures now missing from the record. The head may be a later change, recarved by dynastic Egyptians who inherited the monument but did not know its true history. If so, then Khafre did not build the Sphinx. He repaired it, reshaped its face to look like him, claiming a structure whose origins were already ancient in his time. This would not be unusual. Later rulers often carved their names on structures they did not build. Ramses II took monuments from earlier dynasties. Thutmose IV placed his dream stela between the Sphinx's paws, claiming divine permission to dig it out from sand. Taking credit was common. But taking credit requires something already there. And the Sphinx's body, carved directly from the living rock, cannot be moved, rebuilt, or linked to another quarry. It is anchored in place and shaped only by the forces that weathered it. And those forces tell a story older than dynasties. Seismic surveys around the Sphinx have found underground anomalies, rectangular empty spaces beneath the paws and flanks, suggesting chambers or passages cut into bedrock but not opened in modern times. Some researchers think these may be older than the visible monument remains of earlier building phases lost to history. Whether these chambers exist and what they hold is still guesswork, but the survey data raises a question that cannot be ignored. If the Sphinx is older than we think, what is under it? And what did dynastic Egyptians inherit when they carved a current head onto a body that was already ancient? The geological evidence does not force us to erase Egyptian history, but it does force us to admit the Sphinx sits on a boundary between what we know and what we have forgotten. A monument carved in one age, changed in another, and weathered by a climate that no longer exists, standing silent at the edge of the desert, facing east toward a horizon where the sun rises over a world that has already changed more than once and may change again. The Great Pyramid's sides align to the cardinal directions, with an error of 3 arc minutes. 3 arc minutes is 1/20th of a single degree. For comparison, even modern building work that is considered very accurate is often around 1/10 of a degree. The pyramid, supposedly built with copper tools and no magnetic compass, achieves accuracy 20 times better than modern standards usually demand. But accurate to what? True north is not magnetic north. It is defined by Earth's axis of rotation, the point in the sky that stars seem to spin around. Finding true north requires watching the stars for weeks or months to track their movement and calculate the rotational axis with enough precision. The builders of Giza understood this, and they carved it into stone with precision that shows not guessing, but purpose. Yet the alignment itself raises a question Egyptology rarely answers. Why does such accuracy matter in a building said to be for a dead king? Tombs need protection, not cosmic alignment. Burials need walls, not perfect astronomy, unless the pyramid was never meant to be a tomb. In 1983, Robert Bovell studied aerial photos of the Giza Plateau and saw something that should have been obvious, but had been missed for centuries. The 3 pyramids are not in a straight line. The 3rd pyramid, Menkaure, is slightly shifted to the east, breaking the diagonal line made by Khufu and Khafre. The shift is not random. It matches the pattern of the 3 stars of Orion's belt, Al-Natak, Al-Nalam, and Mintaka, where the 3rd star is offset from the line of the first 2. The match is not rough. It is geometric. The relative sizes of the pyramids match the stars' relative brightness. The angles match. The proportions match. Giza is not just balanced, it is a map. But a sky map needs a date, because stars do not stay fixed. They move slowly through a process called the precession of the equinoxes. Earth's axis wobbles like a spinning top, making one full cycle every 25,920 years. This wobble changes which constellations rise on the horizon during equinoxes and solstices, shifting the star background at dawn and dusk over thousands of years. Ancient sky watchers understood this. Egyptian texts speak of the first time, a primordial age, when the gods set cosmic order. Hindu cosmology describes yugas, huge cycles of creation and destruction. Mayan calendars track precession clearly, calculating dates tens of thousands of years into the past and future. These are not fantasy stories. They are mathematical records of real sky mechanics, and they let us calculate when a certain star pattern appeared in a certain place. Computer simulations rebuilding the sky above Giza over thousands of years show something unsettling. During the 4th dynasty, when the usual timeline says the pyramids were built, Orion's belt rose at an angle that does not match the round layout. But around 10,500 BC, the match is exact, not close, exact. At that time, Orion's belt rose on the southern horizon at the same angle mirrored by the pyramids. The Milky Way, which Egyptians linked with the Nile, stretched overhead in the same direction the river flows on the ground. The sky above mirrored the land below in a symmetry that would not happen again for another 13,000 years. The date is not random. It matches the end of the Younger Dryas, the moment when climate stabilized, ice sheets retreated for the last time, and survivors started to rebuild. That means the pyramids may mark not when they were built, but what they remembered. A memorial date, a timestamp carved in stone to mark when the world nearly ended, and civilization had to start again. And the Sphinx supports this. Its lion-like body faces due east, toward the point where the sun rises at the equinox. But which equinox? The constellations of sunrise change every 2,160 years, as precession moves through the zodiac. During the 4th dynasty, Taurus rose at the spring equinox. During the Ptolemaic period, Aries. Today we are shifting from Pisces to Aquarius. But around 10,500 BC, Leo the lion rose at the equinox, matching the Sphinx's eastward stare. The monument marks the age. It represents a stone lion watching the constellation Leo rise, at the moment encoded by the pyramids behind it. This is not accident. It is design. Mainstream archaeology dismisses this as patenting, saying any group of buildings can be matched to some star pattern if you test enough dates. But that objection misses the precision. Giza does not vaguely resemble Orion. It copies it in scale, proportion, and direction. The Sphinx does not face a random constellation. It marks the zodiac age that matches its own form, and both point to the same date, the same deep time moment, forcing a conclusion archaeology resists but geometry demands. The monuments were designed to speak across thousands of years to future observers who knew enough math to decode precession. They build ancient skies and recognize the alignment. A message written in stars, a timestamp in the only language that survives civilizations. Astronomy, mathematics, and stone. The builders did not expect their names to last. They expected their calculations to last. And they did, carved into 2.5 million limestone blocks aligned to sky cycles that repeat across ages, placed with a precision modern tools struggle to match. The pyramids are not monuments to kings. They are monuments to a moment in time, a boundary between the world that ended and the world that began after. A record left by survivors who understood that to outlast the next collapse, memory must be written in something harder than stone. It must be written in the stars themselves. And we have only just begun to read it. Göbekli Tepe, Baalbek, Yonaguni, and Sacsayhuman have nothing in common geographically. They sit on different continents, separated by oceans, mountains, and thousands of miles. Their builders spoke different languages, worshipped different gods, and left different material cultures behind. Traditional archaeology treats them as separate inventions, isolated advances from unrelated peoples across time. Yet they share something that independent invention cannot explain. At Göbekli Tepe in Turkey, limestone pillars weighing 16 tons stand upright. In circles carved with animal images that require deep anatomical knowledge, scorpions with segmented tails, foxes mid-stride, snakes coiled in exact spirals. Radiocarbon dating places it at 9600 BC, 2000 years before farming, 5000 years before writing, 7000 years before the pyramids. The site predates civilization as we define it. Yet the engineering skill, carving, moving, and raising monoliths without metal tools, draft animals, or wheels suggests organization and knowledge that does not fit simple hunter-gatherer life. The pillars are not random. They align to sky events, especially the rising of Sirius in the southern sky at the time they were built. The geometry is intentional. The astronomy is encoded. 3,000 miles west of Baalbek in Lebanon, the Temple of Jupiter sits on a foundation that may be older than the Romans by an unknown amount. Below the Roman columns are 3 limestone blocks called the trilithon, each about 800 tons. 800 tons is the weight of 3 fully loaded 747 airplanes. Modern cranes that can lift that are fewer than a dozen in the world. And they need prepared ground, hydraulic systems, and computer-controlled accuracy. Yet these stones were cut, dragged uphill for half a mile, and placed so tightly that a sheet of paper cannot fit between them. Roman engineers, who wrote down their methods in detail, left no record of moving the trilithon because they did not move it. They built on a foundation already ancient in their time. A fourth block, even bigger at 1,000 tons, still sits partly cut in the quarry nearby. Left unfinished. The tool marks look like copper or bronze tools, yet metal tools of that age could not cut limestone efficiently, much less shape. Megaliths heavier than any stones moved in recorded history. Off the coast of Yonaguni, Japan, underwater structures lie 70 feet below sea level, terrace platforms, rectangle cuts, and what look like carved stairways, ascending into channels aligned to cardinal directions. Geologists argue about whether the shapes are natural rocks later shaped by people or fully man-made. But sea level has not been 70 feet lower there since the end of the last ice age around 10,000 BC. If the structures are man-made, they predate Japanese written history by 8,000 years. Placing them in a time mainstream archaeology says monumental building did not exist in the Pacific. And in the Peruvian Andes, the fortress walls of Sacsayhuman show stonework that cannot be copied. Blocks over 100 tons locked together in polygon shapes, each surface ground to match the next so closely that the joints stay watertight after 500 years of earthquakes. But here is a detail that breaks the timeline: the stones show no tool marks. The surfaces are smooth, nearly polished, with none of the packing, grinding, or chiseling signs expected from Bronze or Iron Age cutting. Modern stoneworkers trying to copy the method with period tools have not achieved even a close match. The Inca, who used the site in the 1400s AD, said it was built by earlier people, calling it the work of giants or gods. Spanish writers recorded that even the Inca did not know how the stones were shaped, only that they had inherited the ruins from a lost civilization. These places, separated by oceans and ages, share features that isolated growth cannot easily create. Megalithic building with stones beyond known technology, sky alignments encoding cosmic cycles, precise stone fitting needing advanced math and engineering. And a timing problem. They appear in the record before the cultures credited with building them should have had the needed skills. Traditional archaeology calls this parallel evolution, different cultures solving similar problems in similar ways. But the similarities are not shallow. They are structural. The knowledge inside these monuments, geometry, astronomy, engineering, is not rough guessing. It is refined, complete technique that appears suddenly without clear earlier steps, suggesting not separate invention, but shared inheritance. After the Younger Dryas, survivors scattered to safe places coasts before sea levels rose, river valleys fed by highland rain, islands and plateaus that stayed stable. They carried knowledge forward broken and incomplete, but enough to carve into stone when conditions allowed. The monuments differ because the knowledge was not whole. But the core rules survive, that certain angles give stability, that sky cycles control farming time, that measured stone can preserve what memory cannot. Giza is not alone. It is one point in a global web of sites, scattered worldwide, built by cultures that no longer exist, but whose knowledge remained the only thing that can outlast collapse. The question is not whether the links exist. The question is what shared knowledge was important enough to carve into monuments meant to survive the end of worlds. No bodies have ever been found in the Great Pyramid. Not a skeleton, not a bone fragment, not a trace of organic material that would prove a burial. The granite sarcophagus in the king's chamber is empty, unfinished, with tool marks suggesting it was never completed. No hieroglyphs covered the walls, no funerary texts, no inscriptions naming the dead or praying for the afterlife. For a building said to be a tomb, it has none of the things that define Egyptian burials, raising the question, if not for the dead, then for what? Writing, even when it exists, is fragile. Papyrus decays. Clay tablets break. Parchment burns. The Library of Alexandria may be 500,000 scrolls, centuries of collected knowledge burned to ash in hours. Anything written on fragile material is one flood, one fire, one invasion away from extinction, and cultures collapse with the regularity that Earth-time makes unavoidable. Dynasties end, languages die, civilizations vanish, their achievements remembered only in pieces or not at all. The Minans, the Harappans, the Olmec left ruins and objects, but their knowledge systems, writing, mathematics, cosmology are lost or only partly understood. If you know disaster repeats, if you understand climate shifts and cosmic events return across ages, then saving knowledge becomes the main problem. Not saving individuals, but saving knowledge itself. Stone lasts, but plain stone is silent. To encode meaning beyond language, you must use things that do not need translation. Geometry, proportion, resonance, relationships between measurements that speak through math instead of words. The Great Pyramid is not just stacked stone. It is a three-dimensional equation. Its base perimeter divided by twice its height gives pi to 5 decimal places. Whether that is planned or accidental is argued, but the precision is real. The pyramid's alignment to true north, accurate to 3 arc minutes, needs long star observation and trig calculation. The inside chambers are placed by geometric rules that show advanced understanding of angles, ratios, and structural engineering. These are not accidents. They are design. But geometry is only part of the structure's function. Sound studies of the king's chamber reveal odd features that are hard to call coincidence. The chamber, made from red granite hauled 500 miles from the Swan, resonates at a main frequency around 16 Hz below human hearing, but inside the range that causes measurable effects in the body. When sound enters the chamber, certain frequencies grow much louder. Chanting, drumming, or singing at certain pitches creates standing waves that echo for several seconds, longer than the chamber's size would suggest. The granite blocks act like resonators, vibrating along with frequencies that match harmonic intervals, used in musical scales across many cultures. This is not passive building. It is an instrument. Tests with sensitive microphones show the chamber reacts most strongly to frequencies in the human voice range, especially the low tones made by male voices in a steady chant. Some researchers think it was made to strengthen ritual voices, creating an intense sound space with strong psychological effects on anyone inside. But why build a sound instrument as large as a mountain? Unless sound itself was part of the preservation system, a way to store information through vibration, rhythm, and frequency patterns that could be passed by voice and reinforced by the structure's physical design. Knowledge stored not in text, but in vibration, carried through generations by a ritual inside a space, built to amplify and protect specific sound patterns. So the pyramid works on multiple layers, geometric proportions, storing math relationships, star alignments marking sky cycles, acoustic features preserving sound patterns, all combined into one structure built to speak across time to anyone with enough math and observation skill to decode it. This is information architecture, a physical database immune to language drift, cultural collapse, and the decay that destroys written records. Other megalithic sites show similar rules. Newgrange in Ireland, built around 3000 BC, has a passage aligned to the winter solstice sunrise so precisely that light reaches the inner chamber for exactly 17 minutes once per year. It has stayed accurate for 5,000 years, sending a date and sky knowledge without a single written word. The standing stones of Carnac in Brittany are arranged in rows for miles, aligned to lunar cycles and seasonal markers. Their placement encodes calendar information for anyone who understands sky motion, no matter their language or culture. These structures do not celebrate events. They are cord rules. Planet motion, time cycles, Earth's link to the cosmos, information that stays true no matter who reads it or when. And they are built to last. Not centuries, but thousands of years, whole ages, because the builders understood something we mostly forget: civilization is temporary, but knowledge, stored the right way, can outlive the cultures that created. The pyramids are not tombs. They are proof not of kings, but of the idea that what we know can survive. Only if it is built into something harder than memory, stronger than language, more lasting than any empire. They are monuments to the idea that knowledge is worth saving. And that stone, proportion, and resonance may be the only languages that survive the next collapse. The ancient Egyptians had a word for the pyramids that we no longer use. Mer, meaning place of ascension, not tomb. Not monument to the dead, place of ascension, as if the structures were meant not for burial, but for rising towards something beyond human reach. The word appears in temple carvings and religious writings, always linked to change and the crossing between states of being. But ascension to what, or from what? Maybe the answer is not what Egyptians believed, but what they remembered. Every piece of evidence we have examined points the same way, even though it feels unsettling. Water erosion on the Sphinx enclosure that seems older than recorded Egypt. Star alignments pointing to 10,500 BC, before civilization as we define it. Global megalithic sites sharing engineering rules and sky knowledge, despite oceans and ages separating them. Alone, each strange detail can be explained away as coincidence, bad measuring, or biased reading. But when strange details line up, they stop being exceptions and become a pattern, and patterns need an explanation. The usual story says civilization grew slowly and in a straight line, from simple to complex, from mud brick to stone, from village to city to empire. Broken only by local failures and dynasty changes. But geology shows a different story: catastrophic climate shifts, evidence of global impacts in ice cores, sediment layers showing ecosystem collapse and mass extinction, and oral traditions worldwide describing flood, fire, and darkness that match physical evidence. For the Younger Dryas catastrophe, the world nearly ended 12,900 years ago. Not figuratively, literally. And when it stabilized, survivors carried forward pieces of knowledge from the world before. Not full systems, not intact civilizations, fragments, rules carved in stone because nothing else could last. The pyramids, then, are not just 4th dynasty products. They are inheritances, rebuilds of knowledge already ancient when pharaohs claimed them. Built by people gathering along the Nile after climate collapse, encoding information handed down by survivors who understood what we are only beginning to rediscover. That civilizations rise and fall with climate cycles, that what seems permanent is temporary, and that knowledge, if not stored in forms that resist decay, disappears within a few generations after collapse. The monuments were not built to honor the dead. They were built to warn the living, to encode in geometry and stone the truth that humanity has survived extinctional disaster before and may face it again. That the stars move in cycles. That climate shifts follow planetary rhythms. That what we build today may become ruins that future generations dig up, wondering how we did what they cannot. We are not the first advanced civilization on Earth. The evidence: geology, erosion, astronomy, global megaliths suggests cultures existed before written history. But knowledge advanced enough to track precession, build resonant structures, and store information across thousands of years. Most of what they knew is gone. Most of what they built was erased by time, climate, and the growing desert that buried their world in sand. But the stones remain, still speaking to anyone willing to measure, calculate, and see that precision is never accidental. That monuments align to sky cycles encode dates, that erosion reveals climate history, that structures tuned to specific frequencies were designed, not stumbled into. The builders knew memory fails, language dies, and cultures collapse and are forgotten within centuries of their peak. So they wrote in mathematics, in proportion, in star alignment and geometric relationships, in the only language that survives the death of empires. And the message we are slowly decoding as our tools become advanced enough to measure what was built is becoming clear: we have been here before. Humanity has reached complexity, lost it, and rebuilt from fragments. The cycle is planetary, driven by forces: cosmic impacts, climate shifts, solar changes. Beyond our control, maybe even beyond full understanding. And we may not be the last to face extinction. Our climate is changing faster than at any time in the last 12,000 years. Ice cores show warming rates now higher than those linked to past collapses. Sea levels are rising. Ecosystems are destabilizing. And we stand at Giza taking photos of monuments we blame on copperage builders. Unwilling to admit the precision and knowledge inside them suggests inheritance from something older. The stones are still speaking. They speak through erosion that dates them beyond dynasties, through astronomy that marks ages, through geometry that carries math truths unchanged since carving. The question is not whether the message exists. The question is whether we are listening and whether we will act on the warning before we, too, become the lost civilization future. Archaeologists dig up, wondering how we knew what we knew, and why we forgot what mattered most. The sun sets over the Giza plateau, casting long shadows that sharpen the pyramid's edges. The Sphinx remains silent, facing east, waiting. The stones remember what we have forgotten, and they endure, patient, until we are ready to.